Okay, so I'm going to talk about a solution called Urban Observatory, which is about indoor and outdoor air quality monitoring. I'm Dr. Dhaval Thakur. I'm an associate professor in computer science at the University of Bradford. So what does the solution do and what does it contain? So it's made of low-cost calibrated sensor devices. These are mainly PM2.5, PM10, and we know that PM2.5 and PM210 is an effective way of measuring pollution in the air. It also includes temperature and humidity sensors because they are very useful in terms of calibrating the devices. And the calibration is done with reference nodes, one from monitoring station in Bradford and the other one from Urban Observatory in Sheffield. And this calibration is done with number of data science and AI methods, which are listed here. So we've developed two of these devices. The one you see on your screen on the left is the indoor air quality monitoring device. It has a different sort of packaging than the one you see on the right with the pipes, which is outdoor air quality monitoring device. So in addition to the devices, what we have done is we have worked with Bradford City Council in terms of identifying locations for deployment of these devices. And there has been a lot of strategic thinking which has gone behind the selection of locations. That includes, obviously, Bradford is building a clean air zone. It's coming next year in 2022. And what we're doing in terms of selections of schools is we're looking at the locations with respect to the clean air zone, how far they are from the clean air zone, but also what sort of school and educational establishment it is. Is it a primary school? It is a secondary school? In addition to that, as it shows in the right-hand side, we are looking at indices of multiple deprivation, which looks at number of socioeconomic parameters for the area, including education, income, and employment. So that has resulted in identifying 25 locations as shown in the marker in this map. And as I said, it looks at number of socioeconomic and parameters with respect to clean air zone. So in addition to deploying these devices around schools, we also are working with, SCORE project is working with another EU project called Life Critical, where we're working on scaling up monitoring around a park. So this is a Horton Park, which is just at the boundary of city center in Bradford, where we are deploying 10 outdoor air quality sensors in and around the park. And we're also deploying 10 indoor air quality sensors in households around the park so that we can see the interplay and interface between indoor air quality monitoring and outdoor air quality monitoring within the park as well. And we're conducting a study to look at these parameters, but also what activities make a difference in terms of indoor and outdoor air quality. And also what impact it has on health and so on. So what I'm going to do now, so this just shows the locations we have chosen. The black circle shows the indoor air quality monitoring areas, and the red circle shows the areas where we are deploying outdoor air quality monitoring stations. And this is some of the team at work in terms of deploying the sensors, but also LoRaWAN gateway, which allows these devices to be connected to the internet. So part of the solution is an Bradford Urban Observatory as well, which is an open data platform, which allows citizens to see the data coming from this sensors. And we are officially launching this platform, an Urban Observatory, to citizens of Bradford on 25th of November. And I'm just going to briefly show, Bhupesh is going to help me to briefly show the Urban Observatory, how it looks like, and what sort of data we are seeing Bhupesh, if you can please share your screen. If I stop sharing my screen.
Yeah, is it visible now?
Yeah, it is visible. So as you can see, this is Smart Bradford, Bradford Urban Observatory. It obviously has a map of Bradford. Each of these markers show a particular sensor deployed in that particular area. If you can zoom in, Bhupesh, where Horton Park is. So this is the park we were talking about. If you go on the left, at the junction, yeah, click on that, please. So that's HP06 sensor. You select a pollutant, PM 2.5, and if you select it for a week, please. And then it shows you this graph. Now, this graph is quite interesting. It has values literally starting from 2 or 3 for PM 2.5, going up to 200 something. And as you can see, that particular peak, if you can bring your mouse over to the peak, Bhupesh, is just the bonfire night where the value for PM 2.5 reached to 203. Just for the reference, the WHO limit, which is annual average, is 10 microgram per meter cube. This is 203 microgram per meter cube. And the UK legal limit is 25 microgram per meter cube. And that's again annual average. So this is one off, but it is quite high, as you can see. But on the right-hand side, you can see, if you go to November 9, you know, there are other peaks as well, which are also far higher than it should be. So that's 28,172. If you can go to the map again, Bhupesh. So don't click yet. So all the sensors which are there around the park, which are on the busy junction. If you can zoom in, Bhupesh, where Great Horton Park is, the three devices we have. Okay. So if you go on the left, as you can see, go on the left. Yeah. Yeah, so you can see that sensor is at a busy junction, and we're getting the similar sort of reading from the other device, which is next to it as well. And the interesting thing is, if you look at the device, which is just inside of the park, so it's the other further right, yeah, the values are quite different. So if you click on that, and if you put it for 1 week again, and it displays there, and the values are quite low. Literally, the average is 1. We allow floating point values, so that's why. But it is literally 1, which is a stark difference, compared to what you see in the park to what you see on the junctions around the park, and these are quite busy roads. I'll just show one more thing. If you can go up, please, Bhupesh, and then we're almost done. If you look for Leeds Road, if you zoom in, please. Yeah, it's Leeds Road on the right-hand side. If you keep going right-hand side.
So
if you zoom out, yeah. Right-hand side.
This one? Or if you remember, I can.
You can type SK011, SK11. So this is one of the sensors which are Leeds Road. If people know Bradford, Leeds Road is quite busy road, and this is a sensor from one of the schools on Leeds Road, which is generally have very heavy traffic, and you can see the peaks you are seeing. Starting from peaks of 30 to all the way going over 50, quite close to 60 microgram per meter cube, which are quite high values coming from a school on a busy road. Okay, thank you, Bhupesh. If you can stop sharing, I'll just end off with the benefits. Okay, so what are the expected benefits? It allows councils to scale up air quality monitoring. It provides complementary data collection in UK, DEFRA collects the air quality data, but also council monitoring stations as well. It's also about citizen science. You are engaging schools and citizens in measuring air pollution. And the data is absolutely open. And it is also, the platform behind this is linked to open data. So it's a highly structured data as well. One of the things I didn't show in the platform is that you can download up to a month's data from this platform. And we're looking at allowing people to download whole data set rather than up to a month. And it's a real-time data, and citizens and organizations can use this data for analysis. These are the collaborators, contributors, and partners in the project, and these are the schools which have worked with us in deployment of the sensors. And in terms of contact detail, it would be myself. There is email address and the Twitter account listed here.